Have a look at today is something about congruency, about basically working out proofs, trying to prove that something in the form of a triangle, circle or something equals something else. And there are several things we need to know and be aware of. When I was at school, we had lots of proofs we had to learn. Nowadays it's a lot easier. You don't have so many proofs, but there are some with the circle theorems, and we'll look at those as we go along. So let's have a look at what we need to know. Well, what we need to know for circles and for working out triangles in general is that if we've got a triangle, and that's going to be a very bad triangle. Let's see if I can zoom in. I've got too many things in the way. Right. What you can't see is I've just reorganized where I'm working. Now, what I've got is several ways of proving these triangles are identical. The first one is if I've got two triangles and we can somehow prove that these two sides are the same, and we can prove that these two sides are the same, and then that these two sides are the same. This we prove just by having those three sides. It's called side, 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 or better just SSS, and we've proved that these two triangles have to be identical. To have the same sides, they've got to have the same angles, and if they are the same sizes, then the triangles are congruent. They are identical. If we have another two triangles, I'll try and draw some better ones this time. And I'm going to try and prove that these two are identical. They might have here a common angle. So this angle is the same to both triangles. And if I can prove that this side and that side, and it's got to be the side with the included angle, the sides with the included angle, this is side, angle, side, then these two triangles have to be the same, because if this side's the same length and that one and that angle, then this one has to be the same length, and this is side, angle, side, SAS. Let's have another triangle pair. And with this pair, let's suppose we can prove that this angle and this angle here, angle X and angle Y, are the same. And then we can prove that this particular side is equal. This is going to be angle, side, it's got to be the included side, and the angle, which is ASA. And the final type of congruency we can prove is if we have a right angle triangle we know we've got a right angle. We can prove somehow the two hypotenuse are the same, and then we can prove that one side is the same. This is going to be right angle the hypotenuse, and a side, RHS. And these are our 4 ways of proving that triangles are identical. So we've got side, 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 angle, angle, and right angle, hypotenuse, side. And these 4 ways we can use to prove that 2 triangles are identical, congruent, and then we can also use that to prove things like the circle theorems. Let's see if we can do some of these, and what we'll do is we'll have a look at a few examples of congruent triangles and see what we can do with them. Let's zoom in a bit and start with a problem. So let's have here 2 parallel lines, and these parallel lines we're going to pretend are the same length. Down to about there. And I've got a sort of a bow tie shape. Let's give these letters. So this is a question, this is A, B, C, D, and this is, let's have a letter N, it'll do. Now, let's imagine that I'm told some things before we start. We're told that these 2 lines are parallel. So I'm told that AD is parallel to BC. We're told that before we start. And we're told that here N is the midpoint of the line AC. Let's see if we can work out whether these triangles here, ADN and BNC, are congruent to each other. Now, what do we know? Well, we know some things about these angles. This is here parallel lines. There's a line crossing it, so I know that this angle X will equal that angle X. So we can say that, and we can write these different ways, DAN, and I can write it like that to show it's a triangle, an angle for that, or I can write perhaps the angle standard ways of trying to write these things. I can say that that angle equals this angle NCB. So we know those 2 triangles, angles here, these angles are the same. If this is the midpoint, then I know, because I'm given this, N is the midpoint, therefore AN equals NC. Now I'm looking for something else to try and prove. Well, we could say that these 2 angles are equal, but that's not going to help me a lot, because that would give me a side, an angle and a side, but it wouldn't be the included angle. So let's look at these 2 angles here. I know that angle Y equals angle Y, so angle AND equals here BNC. NC. And why do I know that? Well, because these are vertically opposite angles. We knew that those were alternate angles. And this one I was given. So now I've got angle, side, angle. So we've got congruency proved. So I can say that triangle DAN is identical to triangle BNC because of my angle, included side, angle. And these two triangles are therefore congruent. Another type of triangle which is very common to do is this type of triangle where we've got something that is isosceles. So I've got an isosceles triangle and I've got to prove that these two triangles, so let's have A, B, C, D. I'm going to prove that these two triangles are congruent to one another. Okay, let's see what we can come up with. Now, what do we know? Well, this is an isosceles triangle. Therefore, I know that side BA equals side BC because I'm only given the fact it's an isosceles triangle. So we've got one side. And that was given. Let's see what else we know. We can work out a variety of other bits and pieces. We can work out, well, this angle. What can we say about this angle? Well, we know it's 90 degrees, but we may need to try and prove that. So, what else do I know? In isosceles triangle, I know that just because it's told me angle X equals angle Y. So this is going to be BAD. Equals DCB. And we know that those two angles equal one another because this is an isosceles triangle and we were given that fact. I know that this side, BD, is common. So I've got three facts at the moment, but they're not helping me. I've got this two sides, I've got this side, and I've got this particular angle. Now, what else do we need to know? Well, we need to know something about this line. And what they will probably have told you in the question, that this line is either bisects this line, or you might be told that this is a right angle, so you're going to be given generally one of those two facts, so you can actually build this up. If this bisects that, then these angles then will be the same. So I might know that ABD is going to equal DBC. And that is because we're told perhaps that BD bisects AC. And if that's equal, then these two angles must be equal. So I know that side, that angle, that side, but I also know if it bisected that these two sides would also be equal. So that's probably the one I would go for. So side, angle, side. So that tells me that triangle BAD is identical to BDC. Now, let's try a different one. Let's have a kite. And I'm not very good at drawing these things, so we're going to imagine a few bits and pieces. And from my drawing, we're not going to necessarily imagine too much. But I've got a kite, which is A, B, C, D, and what I've got to prove is in this kite that we're told maybe that we've got this line bisecting here. We may be told that that angle, that side equals that side. And I don't know what else we might be told. We could be told that this is just a rectangle, not a rectangle, a quadrilateral, and we've got to try and prove it's a kite. And to prove it's a kite, we'd need to prove various bits and pieces. So always you are going to be given various facts about something. So I may be told that this side equals that side, and we may be told that this side equals this side. So I'm given various things about a kite. So we've got a kite, and we're told that AB equals BC, and we're told that AD equals DC. And we're told that the lines AC is bisected by the line BD. Right, so we're going to try and prove here that some triangles are equal to one another. We could prove that ABN is congruent to BNC. And how do I prove that? Well, we've got side, side, so we know that AB equals BC. That was given. We know that AC is bisected, so we know that AN equals NC, because this is given that it's bisected. And this line here, BN, is common. Side, side, side. If this is true, it's bisected and it's a kite, we also know that angle N is a right angle. Therefore, I can look at the triangles AND, and that's going to be congruent to triangle CND. And the reason for that is we know we've got a right angle, we know the hypotenuse, we know that AD equals CD, and we know that AN equals NC, that was given, and that's a side, so this is right angle hypotenuse side. So we're going through these quite quickly, showing that it's the same basic ideas we're looking for. And when we try some of these, we often end up with looking at particular circles. And when we come to look at circles, we need to look at the circle theorems. So what I'm going to do is I'm going to get out my compass and we're going to try and prove one of the circle theorems to start with. I nearly drew a good circle there with my compass. Okay, let's take this point, which is the centre, and let's draw in what to me looks like a Star Trek type badge. Okay, so I've got my shape. What I've got to try and prove here is that the angle at the center is twice the angle at the circumference. So I've got to prove that angle B is angle O is 2 times angle B. Wrote that round the wrong way. Right, let's go ahead and try and work this out, see what we can do to try and prove something. I'm going to need to put in one extra line, and what I'm going to do is I'm going to put in a line up here. Alright, so let's see what we know before we start. I know that this line equals this line equals this line. So I know that BO equals AO equals CO. And that's because they are all radii. Right, so that's a good place to try and start. If I look at this, I can look at triangle ABO, and I can say that this triangle is isosceles. And I know it's isosceles because it's got 2 identical sides. And these were because they were radii. So let's look at this particular triangle, and let's see what we can say about this particular triangle. I know it's a triangle, and I know in a triangle all angles add up to 180 degrees. There's another fact we know. So if I look at these 2 angles here, I can look at the angle OBA, and I can say that equals the angle OAB, because again it's an isosceles triangle. And you notice I make a lot of cheating here with symbols. Now, what can we say? Well, let's take this angle and we're going to call this one X. Now this angle X I know is part of an isosceles triangle, so my angle BOA is going to equal 180 degrees minus the 2y. Okay. Now I'm going to prove the next triangle. We're going to look at BOC. So we're going to look at triangle BOC. Now this is exactly the same as the other one. Oh dear, I can't spell isosceles. So it's an isosceles triangle, therefore angle A, angle is the same as angle A, and we'll call this one angle B. So therefore I know that angle COB is going to equal 180 degrees minus, in this case, 2A. I could have written it all out again, but I'd like to try and get on today and sort of do some other bits. Right, so what do I know about angle O? Well, angle O is going to be 360 degrees minus X plus B. we already know what angle X is. Angle X is this. And angle B is this. So let's write these out. Now I could have written this just as easily as 360 minus X minus B. And I think I'm going to use that one because it's going to be a bit easier for me. 360 minus X, which is going to be 180 minus 2y. And it's going to be minus this one, which is going to be 180 minus 2a. Let's resolve these by multiplying these minus signs out and work out what we've got. So this is going to be 360 minus 180 minus and minus is a plus, plus 2y, minus 180 minus and a minus a plus, plus 2a. 360 minus 180 minus 180, that's going to disappear. So angle O equals 2y plus 2a. Now if we look at our original triangle and circle, we see that angle B is angle Y plus angle A. And I know that angle O, we've just worked out, is going to be 2y plus 2a. So we can see here that if angle B equals y plus a, and then angle O equals 2y plus 2a, or we could write that as 2y plus a, which is twice that angle. And we've proved one of these things. And in an exam, you might get some of this to do. Circle theorems do come thick and fast. They give you all sorts of things, and once you know some of these things you can work out others. So let's draw in a different one. I managed a slightly better circle this time. Right, let's draw in two triangles. Now, these two triangles I'm going to draw in pen this time, and I'm going to draw them in different colours. So we're going to have a particular segment here, and we've got a triangle. So let's draw in this particular triangle. And typically in one of these problems we've got another triangle, and I'm doing in different colours so you can see the two different triangles. They're going to stand out perhaps a little bit better. Right, so here are our two triangles, and what we have to prove in this is that this angle, which I'm going to call A, equals this angle, which equals B. To do this we're going to cheat, and we're going to put in another triangle. And we're going to do it first of all for the red triangle, so I'm going to draw these lines in red. Now, what have I done? Well, I've just drawn in this same shape that we had before. And we've just gone through all that effort, and so that we can say that angle A times 2 equals angle X. Yeah. I could have said it just the same way as angle A equals a half of angle X. Take your pick, doesn't really matter. Let's look at another triangle, and this time I'm going to take this blue one, and I'm also going to draw in here the same lines here. This triangle is the same as that one, apart from the fact this is moved round here. So I can say that angle B equals a half of angle X. Well, we can see that if they both equal the same, therefore, three little dots, angle A equals angle B. And I have just proved that angles in the same segment are equal. Let's try a different one. I am not doing well on drawing my circles today. Yeah, we're having big problems. Right, let's just I need to get myself the compass tightened up. It's not working well. Yeah. Throw it away and start again, Philip. Right, now I'm going to have a cyclic quadrilateral. So let's draw in my cyclic quadrilateral. And for reasons best known to myself, I'm going to draw it in different colours. Now what I need to prove in this one is that these two angles, A and B, I need to try and prove here that angle A plus angle B add up to 180 degrees, because that is the formula that we've got here, that the opposite angles of a cyclic quadrilateral add up to 180 degrees. To try and do this, I'm going to bring in an extra line. I've got my centre of my circle, and let's bring in a different coloured line here, and we're going to label this O. Well, I've just met this shape already, haven't I? I've got this shape, and that is the proof that we've just done. So if I look at this one, I can quite happily see that this angle here is going to be 2b. And I could go through that extensive proof to try and do this, but we know it is because we've proved the other formula. I also know that this shape is also one of those shapes. So I can say that this angle is 2a. So this is an angle at a point. So point O we know is going to be 360, and that's going to equal 2a plus 2b. Well, if that's true, then 180 must equal a plus b, because I've just divided everything by 2. And if that's true, then angle A and angle B add up to 180 degrees. Let's try another one. See if I have more luck with my compass this time. In here we've got, from the center, I'm just going to draw in a diameter, and I'm going to draw in a triangle. And I've got my center. And what I've got to try and prove in this one is whether this triangle here is 90 degrees. I want to prove that the angle in a semicircle equals 90 degrees. Alright, so that's what I've got to try and prove. Let's help ourselves by drawing in an extra line. And we're going to label this A, B and C. Right, so what do I know? Well, I know that triangle ABO is isosceles. And how do we know it is isosceles triangle? Well, we know that this is a radii, and so therefore I know that this is angle X, and therefore this will also be angle X. These triangles I've drawn different sizes deliberately, but we can also look at triangle BOC, and I can also say that this is isosceles. So therefore, because two radii are equal, therefore angle Y's are the same. Now let's look at the whole triangle. I'm looking at A, B, C. I know that ABC equals 180 degrees. And I know that angle X plus angle X plus angle Y plus angle Y makes 180 degrees. So if those equal that, so I know that 2x plus 2y equals 180 degrees. Therefore, if we divide both by 2, I can take out the 2 into x plus y if you like. Divide both by 2. 90 degrees is x plus y, and x plus y here is 90 degrees. And we're proved. That gives us just one nasty triangle and circle theorem to try and prove, and it's probably the least popular one, which is the alternate segment theorem. Let's have a go at that one. I've got this one to do, and we've got here some sort of tangent going along there. Now I'm going to be awkward, and rather than do any particular one, I'm going to try and do this in a particular way. So I'm going to fiddle things for a minute, and I'm going to take my diameter, and my diameter is going to bisect here. It's going to meet this at 90 degrees. So tangent meets a radius at 90 degrees. So let's see what we can try and work out. Well, let's draw in this triangle. This is the triangle I've just drawn, and I've cheated. I've made it a diameter, and if I've made it a diameter, then we know that this angle here is going to be 90 degrees. Let's put label some things. A, B, C, and we'll have O. So we know that this angle and this angle are the same. If this is 90 degrees, then we also know that this is angle A, let's say, and angle C, let's say. So I know that angle A will equal, well, plus angle C will equal 90 degrees. They have to, because it's the angles of a triangle add up to 180. And we've already got one that's 90. Okay, now I also can look at this angle here, angle B plus angle C, and this will also add up to 90 degrees. So I know that A and C make 90 and B and C make 90. So if we take the common things away, I know that angle A has to equal angle B. And this will apply as I move that line round, and so we've proved that the angle in the alternate segment equals this. We've got it proved there anyway. Finally, I've got perhaps what's considered to be the worst one by most students, but it's not that difficult. I've got my circle, which is a bit faint to have a look at, and what I'm going to do is I'm going to draw in a tangent to this. What I'm also going to do is I'm going to draw in another tangent to this. If this is true, then if I have a radius goes out here, this will meet at 90 degrees, and this is going to be true of this one as well. So we know that these two sides are going to be equal. I know that this is 90 degrees. Let's draw in a line that's common. And what I've got to try and do is I've got to prove that the two tangents, basically these angles are equal. I've got to prove that these two sides are the same length, and we've got to try and work out what's going on. Well, it's a lot easier than you imagine. You see, we know that we've got a right angle here because we've got a right angle because this is where a radius meets a tangent. We know that these two lines are equal. Let's label this A, B, C, D. I know that AB equals BC because they are radii. And I know that BD is common to both triangles. And I've got a right angle, I've got the hypotenuse, and I've got the side. And so therefore triangles A, B, D are identical to triangle B, D, C. And I've managed to prove that by going almost full circle here, by starting off looking at congruency and proving the last one of the circle theorems by congruency. So we've had a look at a few things about congruency, about looking at side, angle, side, 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 angle, side, angle, and right angle, hypotenuse, side, and we've looked at the circle theorems and we've proved all of those. So I hope that's helped, and these questions do come up in the exam and you're asked to prove them, so have a go, see if you can go through and do them and prove that you can do them as well. Thanks for watching, and I hope that I can see you soon next time. Take care. Bye bye.
Here's your reminder. Take a Puritan tablets.